Have you ever stopped to think about the t-shirt you're wearing and wondered why it doesn't just fall apart? Well, it all comes down to a kind of secret armor that's applied to every single thread. Today, we're going to unravel the hidden science of sizing. I mean, you know this yourself, right? Grab a single piece of cotton thread, and it snaps with almost no effort. So how is it possible that modern weaving machines, these incredibly fast, high-tension pieces of equipment, can slam millions of these threads together to make fabric without it turning into a chaotic, tangled mess? The answer is a process you've probably never heard of, but it's the absolute backbone of the entire textile industry. So to really get why this process is so important, we first have to understand the core problem. You see, in its raw, natural state, yarn is, well, it's just not ready for the brutal world of modern manufacturing. For a weaver, it's a huge challenge. Let's break down exactly what's wrong with it. First off, raw yarn is hairy. It's covered in all these tiny, fuzzy fibers sticking out, and every single one of those hairs is just waiting to snag on the machinery, causing tangles and breaks. It's also just plain weak. It can't handle the stress of a modern loom, which means the machine has to stop constantly. That's a huge time and money killer. And if you're working with synthetics like polyester, oh, you get an extra fun problem: static electricity. The threads literally start pushing each other away. It's a weaver's worst nightmare. Okay, so you've got this weak, hairy, static-prone yarn. What do? You can't really change the fiber itself. So instead, the industry came up with this brilliant workaround, a kind of carefully engineered recipe designed for one thing: strength. And that solution is called sizing. You can think of it as giving each individual thread its own temporary coat of armor. It's a protective, sticky film that just completely changes the yarn. It makes it smooth, it makes it strong, and it gets it ready for the loom. This one step is the secret sauce to making high-speed weaving even possible. So what's actually in this recipe? Well, the main ingredient is an adhesive, basically glue. For something natural like cotton, you can use simple starch. For synthetics, you use something more high-tech like PVA. Its job is to paste down all those little hairs and add strength. Next, you need a lubricant like a wax or oil to make the yarn slippery and cut down on friction. Then you add an antiseptic, which is just a preservative to stop things like mildew from growing on it. And finally, sometimes a weighting agent like china clay is tossed in to give the final fabric a heavier, more substantial feel. But here's where it gets really interesting. It's not a one-size-fits-all kind of deal. The recipe has to be tailored to the fiber. You know, cotton is like a sponge. It's absorbent. So those old-school ingredients like starch and animal fats work perfectly. But something like polyester, that's basically plastic. It repels water, it builds up static like crazy. For that, you need a totally different chemical toolkit with synthetic polymers and special agents to fight that static. All right, so we've got our custom recipe. Now, how in the world do you apply it perfectly to thousands of threads all at once? Well, for that, you need a pretty incredible piece of engineering. You need the sizing machine. Check this thing out. This is what's called a slasher sizing machine. I know, it looks like a beast, super complicated, but don't worry, the yarn's journey through it is really just 3 main zones. We're going to watch it go from a bunch of individual raw threads all the way to a finished, ready-to-go weaver's beam. So the journey kicks off in zone 1. You've got hundreds, sometimes thousands of threads all unwinding from these massive spools. They get arranged into a single wide sheet, and then they take a dive right into the size box. Think of it like a hot tub full of that liquid size recipe. The yarn gets a good soak to make sure every last fiber gets a perfect coating. Okay, next is the most critical and energy-hungry part of the whole process, the drying zone. The wet, sticky sheet of yarn has to weave its way over a series of giant, steam-heated cylinders, and this has to be done just right. If it's too wet, you get mildew. If it's too dry, the size coating gets brittle and cracks. It's a real high-wire act. And finally, we hit zone 3. After the yarn is dry, it's not a bunch of individual threads anymore. It's basically one big, solid sheet of yarn that's all glued together. So a series of lease rods have to get in there and carefully split every single thread apart from its neighbors. Once they're all separated, the newly armored threads get wound onto the giant weaver's beam, and it's officially ready for the loom. The whole process is a marvel of engineering, really, but the most incredible part is just how completely the yarn is transformed. I mean, the difference between the yarn that goes in and the yarn that comes out is like night and day. I mean, just look at this side-by-side comparison. The yarn that went in was hairy, weak, and pretty flexible. What comes out is perfectly smooth, way stronger, and a lot stiffer, which makes sense since all those fibers are now glued together. It's also less absorbent, of course, because it has that protective film on it. But when we say stronger, what does that actually mean in numbers? Well, here's the headline figure. The breaking strength of the yarn goes up by a massive 20 to 40%. And let's be clear, this isn't just a minor improvement. This jump in strength is the single biggest reason why modern, high-speed, automated weaving is even possible. It's why we have affordable clothes today. So, to sum up the complete upgrade, strength and abrasion resistance, way up. That fuzzy hairiness and annoying static, way down. Sure, the yarn gets a little less flexible and a tiny bit thicker, but those are really small trade-offs for the massive gains in performance. You're basically turning it into a weaving superstar. Now, this all sounds pretty amazing, right? But it's not a perfect silver bullet. Achieving this kind of performance comes with its own set of challenges and, yeah, some significant costs. It's a trade-off that manufacturers are dealing with every single day. So here's the other side of the coin. Those sizing machines are incredibly expensive. The process itself burns through a ton of energy, materials, and labor. And remember that coat of armor is only temporary. After the weaving is done, you have to get it off, which means another expensive process called desizing to wash all those chemicals out. And that, of course, creates a lot of wastewater and pollution. On top of all that, if you don't do it perfectly, you can get faults like size spots that can ruin entire batches of fabric. And this quote really captures the core dilemma perfectly. You're trying to create a recipe that's tough enough to survive the absolute violence of a modern loom, but at the same time, it has to be weak enough to wash away easily and completely after its job is done. It's this delicate chemical balancing act between performance and removability. And that really brings us to the big question for the future. We know sizing is essential, it's not going anywhere, but it's also a very resource-intensive process. So as we all start demanding more sustainable, more environmentally friendly products, the pressure is on the industry to innovate. So how will this secret armor evolve? How will it get greener, more efficient, and smarter for the next 100 years of textiles? That's the challenge that lies ahead.